Scalability starts simple, then grows intentionally. When I think about scalable web app, I start with the real job, a SaaS dashboard or e-commerce product that begins with one application server and then grows into a multi-node service. Before we pick components, be clear about the workload. This design has to handle client traffic, load balancing, application servers, database, cache, CDN, background jobs, queues, monitoring, and safe deployment strategy, not just a clean demo request. The first diagram usually looks fine because it only tells the happy path story. For this topic, that naive version is usually one web server, one relational database, an application state living too close to the machine. I still start simple on purpose. The smallest version that can work here is one web server, one relational database, an application state living too close to the machine. That gives the team a baseline before complexity earns its place. Next, I walk one normal request or event through the simple design. That is where the useful questions start, because the path reveals what each component actually owns. The problem is not that the simple version is wrong. The problem is that it ignores what production will demand next. The database becomes a bottleneck once reads, writes, and reporting compete for the same resources. The first production pressure usually shows up here. The database becomes a bottleneck once reads, writes, and reporting compete for the same resources. That is the moment when a pleasant diagram turns into an engineering decision. Then operations gets involved. If the design cannot be observed, rolled out, and recovered safely, the system is already too expensive to own. In this topic, the pain looks like session state, file handling, and background work make horizontal scaling harder than the first diagram suggests. And then comes the part junior diagrams almost always skip. Without observability and safe deployments, the system can scale traffic while still scaling incident pain. That is where production-grade thinking separates itself from feature demo thinking. So the better design adds only what solves a real problem. For this topic, that better shape is a stateless app layer behind a load balancer, cache for hot reads, CDN for static assets, queues for slow work, and monitoring around the critical path. This is what you gain from the stronger design. You gain resilience, better performance, and room to scale without jumping straight to unnecessary complexity. Those gains are why the extra complexity is sometimes worth it. But there is always a bill to pay. The cost of the stronger design is every new layer adds operational work, consistency questions, and cost you have to justify. That trade-off is the real system design conversation. Now I challenge the design with a failure question. Ask how the app behaves when the database slows down, the cache misses spike, or one deployment introduces a bad build during peak traffic. If the diagram cannot answer that honestly, it is not ready. So the final architecture story is simple. Trace one request from client to CDN, load balancer, app tier, data layer, and async workers, while showing where scaling decisions are introduced on purpose. That is the version I would be comfortable defending in a serious review. If you remember one thing, make it this. Viewers can design a scalable web app without over-engineering from day one. Good system design is a judgment loop, not a memorized answer key.